Now let's move on to this example, subarray with given sum. The gist of it, we have here two test cases. For instance, for each test case, the first number is the amount of array in the list, 5 in this case, or 10 in these other cases. And the second number is the sum that we have to find, and what you have to return is the continuous subarray which adds to the given number. In these cases, the first continuous subarray, that means we should be able to 2 plus 3 plus 7 is 12. In this case we have from 2 to 4 is one indexed, I guess. And this we have to find what is adds up to 15, which is 3, 6, 4, 15. That's correct. Now that's interesting. Now let's move. In these cases, it's more comfortable to look at a direct how we do it. So in case here we have okay. The first things is I will need to do some boilerplate as usual. And in this case we have first we have to read n and some expected as yes. And again this one. Sound good. Well, this might be interesting. Yes, this usual stuff. Okay, that's exactly what and I need to define a method which returns that returns the expected result. So let's define this method. That is much usual boilerplate. Okay, and then we go to the real issue. Well, of course, I'm trying to achieve a linear speed here. So what I do that? Let's see how let's read the first one. And okay, we need a running sum starting from running sum starting from 1 is 1. Running sum starting from 1 is here 1. Now we have 3 and 2 because now what we have to here is this is pretty much, I don't know how much. Now you would have here 3, 2. Now we would have 6. 2 to 3 would be 4, and 3 to 3. Now I was wondering if we could do this with dynamic programming, starting from the end. Well, I don't know. Let's follow up this idea too. Let's start it from the end instead. Well, I don't know. That's actually not a good idea. Let it actually start from the beginning. And we'll keep a hash map actually. Okay, as we call some expected. Well, let's call S as a we call, and just enumerate L. Well, I would not hope. It might become quadratic pretty soon now, if you think about it. Let's move on and let's see what it works. Well, not well, let's move it. I would say that Sj is equal x get j 0 plus and if xj is equal to the expected sum, then we can return actually j plus 1 1. Not sure. It kind of looks quadratic, but of course and the expected result would be print AB. 3536. Well, not exactly what I was expecting. Okay, let's go through with this one. In this case, anyway, let's check it. Okay, let's see what it works with. Is it actually working? Now, okay, let's see. First step, I'm going to for it. I'm going here, and I'm actually not to do, and I'm actually skipping it, not because not what I want to do here. Well, so now is more like it. Now, of course, yes, I'm not skipping it. 3 to 5. It will be 4 to 6. 4 to 6, 4, because actually it's correct. It's now finding, it should be finding the first one and not the latest one. So I should do it this way and return the higher number. Well, because it actually should be returning by first one. Okay, and now is the expected result. Let's submit it. Let's see. Okay, there is one none type. And in case cannot be found, -1, -1. Okay. Should be returned. Should that what should I be printing? Okay, I've moved on and got a real test because, as I said, we needed to find the first one before this in case for this reason we have to start from the beginning, and in case none is found we have to return none and print -1. Let's add the test case for this. Well, just okay, and that is what I would expect. And let's see if okay, and that's correct. Well, it's quadratic actually. I don't know if it is possible to get better. Well, I don't know, quadratic, kind of. I don't know if it is possible to get a better runtime. Well, there is actually another way to solve it, just to keep it a single sum. Well, this is how it works. We start from index e if 0, and we keep the sum of the first element, and we remember that we start from j 0. Well, let's start. Let's say let's call it a the starting and b the end element. We move b to 1, all keeping a still equal to 0, and you know, now the running sum is 3, still less than 12. We move to the second element, b equal 2, and now the running sum 1, 3, 1, 2, 3 is 6, still less than 11. We still keep the first element equal to 0. Now we move to b4, and we add the latest one, and we now get this running sum, which is 13, which is greater than 12, which is g equals 0. Now we'll start removing, as it is greater than the expected sum, we'll start removing, we start increasing j, and that is a, and if you increase a, we see that the sum between 1 and 3 is 12, which is actually the expected, our expected result. Okay, now I thought of an alternative. I coded this scenario that I explained before. Now I've initialized a and b, that are the left and the right margins that I'm trying to find, and b will be exactly the index that I will scroll through the list that I use to scan the list. So b will go from 0 to the length of the list. So while the sum is initialized to 0, now whenever I go and scan and find out, now for instance in the case I would be b equal to 3, and would be this situation, and the sum was a 6. Now that would be the condition 6 plus 7 is greater than 12. It will be b, the running sum here, plus the value at index b. In this case, as I said, I will increase the value of the other extreme until I can get a sum which is lesser or equal to the sum, the expected sum, this one. And this is what I do first. Then if the sum, the current running sum plus the current element is still less than the expected sum, then I do sum it. I do sum the current element. Otherwise, if it is equal, I've found my element, and that's what is returned. If I cannot find anything, I return none, which then interpret as a -1 as I submitted, and it gave me a correct answer as I replace the name of the method here. And that's how it's done.